Federal University of ABC. ABC is not because any kindergarten thing or we like, I don't know, Jackson 5 famous hit. Is because it's a metropolitan region next to São Paulo. So I was born in B. It was the name of the city. And I'm from a lab that tried to work with naturalistic stimuli and try to work with neuroscience of social affective neuroscience in general. And I have a bachelor degree in science technology, but also in neuroscience. But I also have a background in audiovisual. I work with audiovisual stuff like 12, 13 years ago. And I always wanted to try to mix both fields. And I'm talking to my advisor, Claude, and he starts to say, okay, there's some really cool things happening in neuroimaging with naturalistic stimuli. And I'll try to present a little bit of what I'm saying. I'll pretend that I'm not nervous, so pretend that you guys understand it all, okay? So, okay, and of course, Felipe Toranandes, a friend of mine that is working with me in this collaboration. And of course, right, my interest in this field is because, okay, I have this audiovisual background. And to me, when we work with neuroimaging, especially naturalistic neuroimaging, when I was looking in the literature, I realized that we weren't not so much worried about the content of the stimuli. You know, we present it and say, oh, look, there's naturalist tasks, but we're not looking to the content. We're not looking to the self-report of people. We're not sometimes even collecting self-reports. And to me, and maybe my work try to show that it's important to even pay attention to that, because sometimes things can pop up differently. So, okay, I love huge names. So the association between Connectome fingerprinting and global metastability is modulated by cognitive states and brain health. I will start talk. I speak really fast in Portuguese, so I try to slow down in English. But I'll try to explain what is a fingerprinting. I don't know if everybody here is aware, but the idea is Emily Thing in 2015. She presented that FC profiles presented patterns that everybody have some variability, and this variability is strong enough to identify people actually. So if I get the fMRI scan from everybody here, and then I don't know, 1 week later I get another data set and I scramble everybody and then I correlate everybody, your own FC will be more correlated with your own FC, which sounds a little obvious, but thinking about connectivity is interesting to work with this, because we now can consider the variability in ourselves as a tool. And then that was really interesting. And then some work came up later to try to enhance a little bit this identification. So, okay, I can have my identifications, but I can disentangle the fingerprinting matrix into, this is an example of a Mikko that I can disentangle into the main diagonal element is the I self. So it's how much I correlate with myself, and I others is how much I correlate with the average value of the same data set. So now I have two indexes. I have an index of stability within the subject, and I have an index of similarity between the subjects. And actually, I didn't put here, but there are a lot of work showing that it's not just cool statistical things that happen with neuroimage, but there's some correlation between friends presenting closer fingerprinting with, or people that kind of, depending on the context, living together, they present a closer fingerprinting. Twins, if they are, I don't know how to say in English, univitelline? I don't know, but depending on your twin, you present a higher fingerprinting. So it seems that it's not just something that happened with data, but actually something that kind of consider the subject and the context these subjects are in. And in 2023, we found out this really cool paper from Dr. Sorrentino, presenting that okay, we can enhance even this this identification if I consider this work was in MAG. If I choose, okay, if I get which one? Okay, if I get the whole data, okay, I can identify some of us well. But if I consider just the non-linear part mostly, so the avalanches patterns here, the identification goes up. So it was interesting to us to look. Okay, it sounds that the nonlinear dynamics are kind of driving the identification. So my thought and my advisor thought, okay, can we replicate this in fMRI? It's a different neuroimaging technique with different resolutions. And Dr. Sorrentino, more spoilers. Okay. Dr. Sorrentino didn't do anything with networks. We were interested in working with network level. So this association can be found within the networks. And because I have my own personal interest in narratives, and because to me, considering narratives is not just something cool, but actually the way I'm presenting right now, I'm creating a narrative. You guys are watching, you're creating narratives. When we go to therapy, when we have more narratives in our life and we construct the world in narratives more than we think. And then I think that we don't consider that so much when we do science, considering neuroscience. That can help a lot because, I don't know, thinking about even, I don't know, internet, political discussions, everything is about propaganda. So I think it's not just a fancy thing, but actually it's really important to think about doing this so kind of effective social neuroscience. So that was the thought. That, okay, let's just replicate it and see that if metastability will brain dynamics will correlate with fingerprinting. So that was the data set that I used. Is called Naturalistic Neuroimaging Database. Is a database of 10 movies that people watched entirely inside the MRI scan. I didn't use all of them. We have 10 movies distributed, 86 people distributed in 10 movies, but not all of the movies have the same amount of people. So I choose the 2 movies with most subjects, and they have really different narratives. So one is a romantic comedy, really high-paced. The other one is a documentary, really boring. And and then, okay, I did Gordon parcellation. I work with another parcellation, but mainly the Gordon parcellation. And I lose a little bit here, but the metastability calculation that I use here in fMRI was a really simple one. It's really I did a spatial calculate the spatial coherence. That is I don't know, covariation between regions in each time point. And then I take the standard deviation. So I'm seeing, okay, how much the amplitude of this coherence in a distinct moment of time. And then I did the calculations that I previously talked about. So I did the calculation of I-self, I-others for this data set. So I have now this value for stability within the subjects inside the movies, and the similarity between subjects also inside the movies. And then I just fit a model between those metrics, controlling for age, sex, motion parameters, and I build 3 kind of models. One is a whole brain model. So, okay, I want to see if there's a correlation between identifiability and metastability and for the whole brain. But then I fit another model considering the networks, each one with different number of rights. And then I did the one that I was interested, that I separate in the two movies to see, okay, there's a movie that is better to predict identifiability compared to the another one. And that was something interesting that I found out, because I was expecting, okay, I was really expecting positive correlation. And then I found out a negative correlation. And I was thinking, okay, I did something wrong, but maybe, right? But the idea is I will start to, okay, think a little bit. Oh, I found the association, so I kind of replicated, okay. But that's something worse, not worse, better happens, because eye orders correlate better. So again, we're talking about the stability within the subjects and the similarity between the subjects. And seems that the brain dynamics is better predicting the similarity between the subjects, and not the stability. Also is predicting, but is predicting better. So, and of course, this is a going on project. So I'm hoping to talk to you guys, and you guys help me to understand, because I don't can make sense yet about all the results. I have some ideas, but I would love to talk and work together here to understand it. But okay, I have this association, and that made me think, okay, so I will try to start to work the two measures together and see what happens if I consider both. And then I start thinking, okay, let me consider the two indexes and see how the association goes. And I go inside within the networks, and all the networks presented relationships. So again, we can we're seeing a good relationship between brain dynamics and identification, but some networks seems more ioders related or negative related compared to some of this, and I am not sure yet what that means. I have some intuition, but we can talk more later based on what people are watching, but are only intuition. But this is one of the questions I want to answer. There is a correlation within the networks and with these measures, and yes, we found it too. And then we go to the question that I was hoping that, okay, can we find the difference between the two movies? These are the 500 Days of Summer is the romantic comedy, Citizen 4 is the documentary. And we found out, okay, both measures seems to be correlated with metastability, but clearly one movie seems to be better predicting than another movie. I have some thoughts about it. I think because we're talking, I think that because they're watching the same thing and their brain dynamics kind of be driven by the stimuli, more chaotic brain dynamics will disrupt this identification because they are being driven by the stimuli. So I think that's the difference between the MAG result, because in the MAG they were in the resting state, so they're not being driven by anything, and that will be enhanced in the chaotic system. In the brain dynamics will actually present an enhancement in identification, but I'm not sure yet how to make this sense of this. But then, okay, I want to see, I don't to look really based on statistics to another movies, but I want to test it to see if I could see it in different movies, in different data sets, in different tasks, neurological conditions. So I went to look to those data sets to see if I can see this correlation, this association in different data sets. And I found out that, okay, considering I'm skipping the time, okay. Yeah, I found out that, okay, I have this relationship in a lot of different movies with different characteristics. I have this, this is a data set of people that watch the same stimuli, but with a spoiler or with an original, and we have a difference. So it seems that people watching the same stuff can have different relationship with the metrics depending on how they are watching. Also, I tried in ACP, and we also find out, but with different configurations, especially with tasks that seem not related so much. And I try to minute scan, also find out some relationship, but kind of varying across days, and comparing different neurological conditions. We found out, okay, with myself, we also found out the relationship, but it sounds that depending on the neurological condition, this relationship seems to be differently. Of course, I have to look to adult. I have a lot of questions that those answers show, but I won't talk about all of that because of time. But I have, of course, a lot of limitations, and what Shayla said, we have a lot of temporality to consider, and emotion, and I'm using simple measures, but the idea is, okay, I have the relationship. We're founded as and it can be a really cool thing to work with, to kind of start with characterizing better our stimuli. And that's it. We can talk more in the poster. I want to thank for everybody, friends, people that come here from Brazil, my cat that raised my cold a lot of times. And well, thank you very much, guys. We can chat later.
Thank you. I was wondering about the differences across the films and